Okay, hello everyone. So today's topic is Kirchhoff's current law and Kirchhoff's voltage law. This topic is one of the most important topics of our syllabus, and up to last chapter, this topic will come. So remember the rules, remember the formula, everything like how to make circuit diagram, how to solve circuit diagram, because in all circuit diagrams it is not possible to calculate equivalent resistance. If there are multiple batteries, then you have to use Kirchhoff's current law and Kirchhoff's voltage law. So please learn both these rules very effectively. Okay, so first we'll discuss Kirchhoff's current law, then we'll come to Kirchhoff's voltage law. Okay, 1 second. Okay, yeah. So first is Kirchhoff's current law. So what is basically Kirchhoff's current law? So according to Kirchhoff's current law, at a node, at any point in a circuit, total incoming current will be equal to total outgoing current, because current or charge can never accumulate at one point, because current in a wire flows when there are moving electrons. Electrons are negatively charged and they repel each other. So at any point in a circuit, electrons can never accumulate. Since charges can never accumulate, it means the total incoming charges will be equal to total outgoing charges. So Kirchhoff's current law says that current entering the node equal to currents leaving the node. So total incoming current will be equal to total outgoing current. By sign convention, we can take the incoming current to be positive and outgoing current to be negative. But remember, why Kirchhoff's current law is applicable? Because charges can never accumulate at any point in a circuit. So total charge coming at a point will be equal to total charge leaving from that point. It means total current arriving at a point will be equal to total current leaving that point. Okay, now moving to one very simple numerical. Suppose at this point 6 ampere current is incoming. So there are two wires. So 3 ampere and 3 ampere will be outgoing. So if you look at this point, the total incoming current will be equal to total outgoing current. Okay, we'll take one more numerical. Suppose at this point E. Now we know that the incoming current is 20 ampere, incoming current is 6 ampere, and the current that is going in this branch is 10 ampere. So what will be the current in AB? So IAB will be equal to total incoming current is plus 20 plus 6. Sign convention, the incoming current is positive, the outgoing current is negative, so minus 10. 20 plus 6, 26 minus 10, the answer will be 16 ampere. So the current in this branch will be 16 ampere, and AB will be 16 ampere. So this is how you have to use Kirchhoff's current law. Okay, now coming to Kirchhoff's voltage law. Okay, now before discussing Kirchhoff's voltage law, remember one thing, that electrostatic field is a conservative field. Conservative means in a closed loop, total work done will be zero. Like if you take a mass m to a height h, the work done while you take up will be plus mgh, but while it comes down will be minus mgh. So total work done will be zero. Similarly, in the case of electric field, the total work done in a closed loop will be zero. Okay, now what is Kirchhoff's voltage law? So according to Kirchhoff's voltage law, the sum of voltage rise across any loop is equal to the sum of voltage drop across that loop. It means the voltage that will increase will be equal to voltage that will decrease. So in this electric circuit, the voltage is increased by battery. So battery increase the voltage by 5 volt, and voltage drop is there in resistance. Suppose in this resistance the drop is 3 volt, and in this the drop is 2 volt. So if we'll see, the total increase in voltage is 5 volt and total decrease is 3 plus 2, 5 volt. So always remember, in a closed electric loop, in any closed electric loop, total increase in voltage will be equal to total decrease in voltage. Okay, now how to use Kirchhoff voltage law? The rules are very important. Okay, so suppose this is a resistor in which current I is there, and you are moving from A to B. You are moving from A to B. So if the direction of your movement is parallel to direction of current, you have to write minus IR. And the opposite one, like you are going from B to A, but current is opposite to your motion, then you have to write plus IR. So if your direction and direction of current is parallel, minus I into value of resistance, and if your direction is opposite to direction of current, then plus I into resistance. These two rules are very important. Okay, if there is an electric circuit, if there is an electric battery in your path, and suppose you are going from A to B. So if you are going from A to B, the first terminal that you will meet will be positive. So if you meet positive terminal, then you have to write minus E. And suppose if you are coming from B to A, suppose you are coming from B to A, then the first terminal that you will meet will be negative. So you have to write plus E. So all four rules are important. If the direction of your motion and direction of current is parallel, minus IR. If direction of your motion and direction of current is anti-parallel, plus IR. If in an electric circuit, if you are moving and if you meet the positive terminal first, if you meet the positive terminal first, you will write minus E, and if you meet the negative terminal first, you have to write plus E. So how to use these rules now? Okay, suppose this is an electric circuit where potential of battery is E. There are two resistance R1, R2, and there is current I in the circuit. So what you have to do is you have to first put nodal points. Nodal point means A, B, C, D. Now what you have to do is you have to write the path. Suppose I start from A, so I'll go from A to B, then from B to C, then from C to D, and from D to A. So always remember the first and last point should be same, because Kirchhoff's voltage law is only applicable when there is closed loop. So if you are starting from A, you have to end at A, but you can take any path you want. Okay, so the path is A, B, C, D, A. So if we'll go from A to B, if we move from A to B, there is nothing in between. But if we'll move from B to C, so when you'll move from B to C, you are going from B to C and current is also from B to C. So you have to write minus IR1, minus IR2. So minus IR1, minus IR2. From C to D, there is nothing, no battery, no resistor. From D to A, if we'll move from D to A, you will first meet the negative terminal. So we'll put plus E equal to 0. So this is the Kirchhoff's voltage law equation for this electric circuit and for this path, that is A, B, C, D, A. Now I take one more example where the circuit will be complex. Suppose in this circuit, we have two battery, E1, E2, two resistance R1, R2. Now what I'll do first is I'll take one battery, any battery you can take, and I'll take I current from that battery. The current will reach at this point. Now at this point the current will divide. Suppose I1 goes on upper path, then the current that will be remaining will be I minus I1, it will go in this path. So this I1 will move like this I minus I1 will reach here, both will add up and the current that will again reach the battery will be I. So you have to remember that the total current coming outside from battery will be equal to total current again entering the battery. Then only your Kirchhoff's current law will be correct, else it will not be correct. Now we'll take two loops. Suppose one will be A, B, E, F, A. Another will be B, C, D, E, B. Now for A, B, E, F, A, from A to B there is nothing. From B to E, you are moving from B to E. Current is from B to E. So what we'll write is minus I1 into R2. From E to F there is nothing. From F to A there is negative terminal first. So we'll write plus E2 equal to 0. So this is first equation. But we have two variables. The variables are I1 and I. So how to find the second variable? So we'll write one more equation. So B, C, D, E, B. From B to C there is nothing. From C to D you will meet the positive terminal first. So you will write minus E1. From D again we have R1. So current in this direction, you are moving in this direction. So you have to write minus I1 R1 because current in R1 is I1. From D to E there is nothing. And from E to B, you are moving from E to B, current is from B to E. So you have to write down plus I minus I1 into R2 equal to 0. So if you will solve both these equations, you will get value of I and I1. Okay, now I am sending a sheet to you based on Kirchhoff's current law and voltage law. You have to solve that sheet, and if you have any doubt, you can WhatsApp me. Okay, bye bye.